Last week we learned about atoms. If you remember, an atom is the smallest particle of an element that we can get down to where it's still an element. This week we're going to talk about compounds. A compound is something that's made up of at least two different elements. It can be 2, 3, 4, 5, or 100. The important part is it's multiple types of elements bound together. There are two main types of compounds. There's ionic compounds and molecular compounds. What we're going to work with most in this class are ionic compounds, but we are definitely going to deal with some molecular compounds. Where you really get into molecular compounds is organic chemistry, and that's not what we're going to be doing. The molecule here on the left is a molecular compound. These are carbons with oxygens and hydrogens. It's multiple elements together, but they're held together by covalent bonds. You don't know what covalent bonds are yet, but that's really what's going to determine the difference between ionic and molecular compounds. We'll learn about that later. On the right is an ionic compound. This is sodium chloride or salt. Here we see that there's sodium atoms in with chlorine atoms, and actually there's sodium ions with chloride ions. So ionic compounds are made up of a metal cation and a non-metal anion. Okay, that's going to be the key to tell the difference between ionic compounds and molecular compounds. An ionic compound is going to have a metal and a non-metal. And when you have the metal cation, remember cations are positive, a non-metal anions are negative. They're going to exist in a mixture so that the positives and the negatives balance each other out. And when they come together, like you saw on the last slide, they come together in what we call a crystal lattice. It's sort of an organized structure, and if you actually look at it, it really helps to take those charges and balance them out. We call ionic compounds salts. When you hear salt, you think of sodium chloride. That's the prototypical example of an ionic compound, but in general, anything that's an ionic compound can also be called a salt. In contrast, a molecular compound, even though it's made up of two or more different elements, they are all nonmetals. So if you want to tell the difference between an ionic compound and a molecular compound, look and see if there's a metal involved. If there's a single metal in there, it has to be an ionic compound. Molecular compounds, there's no charges whatsoever. We don't have to worry about charges. Instead of being in a crystal lattice, they're actually in molecules. And a molecule means it's made up of a molecular compound. So over here we have a molecular compound. There's CO2, carbon dioxide. Carbon and oxygen are both nonmetals. And then we also have O2 here. And we'll see what O2 is. O2 is a molecule, but it's not actually a compound because they're both oxygen. If there's two atoms, even if they're the same element, it's not a compound. A compound has at least two different elements. So ionic compounds and molecular compounds have very different properties. I always suggest thinking of examples of an ionic compound and a molecular compound and think about what you know about them. A lot of these properties you already know. So think of an ionic compound. Let's start with salt. It's a crystalline solid at normal temperature. At room temperature, it's always going to be a solid. Pretty much all ionic compounds are going to be solid at room temperature. Molecular compounds can be gas, liquid, or solid. So CO2 at room temperature is a gas. Water is a molecular compound. It's a liquid at room temperature. Sugar is a molecular compound. It's a solid at room temperature. Ionic compounds, you don't deal with them very often in large pieces in regular life, but if you could, you'd see that they're very hard and very brittle, whereas molecular compounds are generally pretty soft. Think like plastic. In terms of melting and boiling points, ionic compounds have very high melting points, very high boiling points. You imagine trying to melt salt. It's just not going to happen. Whereas sugar, you can melt just on your stove. Density, ionic compounds are more dense than molecular compounds. And what's going to be really important in later lectures down the road, ionic compounds are strong electrolytes. An electrolyte is something that conducts electricity. When you put ionic compounds in water, an aqueous solution, it conducts electricity. Molecular compounds don't. Salt and water will conduct electricity, sugar water will not. Very similarly, ionic compounds, if you can melt them, if you get it hot enough to melt them, they'll conduct electricity, but molecular compounds, no matter what form they're in, they're not going to conduct electricity. So these are our pictures again. So here is our sodium chloride, our salt. It's an ionic compound. You have the sodium ions and the chloride ions in a crystal lattice, and they form this cubic structure. Carbon dioxide is a molecular compound. This is our molecule of CO2. I mentioned O2 earlier. Oxygen is a molecular element, not a molecular compound. There are two atoms, and it's not ionic. There's no metal, but because they're both oxygen, it's not a compound. So what I want you to do is pause the video right now, and then go through the list and try to identify each compound as ionic or molecular. So pause it now. Okay, so let's go through and look at these. So we have CCl4. The key here, as I mentioned earlier, is to figure out, is there a metal involved? So is carbon a metal? If you look at your periodic table, carbon is on the right. It's not a metal. Chlorine is on the right. It is a non-metal. There's no metal, so this means it's molecular. This is calcium fluoride. Calcium is on the left side of the periodic table. It's a metal. So without even looking at fluorine, we know that calcium fluoride is an ionic compound. This is sulfur hexafluorine. This is a molecular compound. Both sulfur and fluorine are non-metals. Copper is a metal, so copper carbonate is an ionic compound. Water is a tricky one. You can probably find periodic tables where hydrogen is in the top left corner. The periodic table we have in our class is hydrogen is in the top left corner. But actually hydrogen is a non-metal. So we consider water as a molecular compound. That's kind of a tricky one. That's not something you would have to worry about on an exam or a quiz. So again, I want you to pause the video, try to answer these on your own, and then I'll give you a second, and then I will go through them. Okay, so which one has the highest melting point? To figure this out, we have to first figure out whether any of them are ionic or molecular compounds. So the first one here is cesium chloride. That's ionic. Carbon tetrachloride is molecular. If we went back to that table earlier, we would see that the ionic compounds have higher melting points. So cesium chloride has the higher melting point. CO2, remember, is molecular. Calcium fluoride is ionic. Ionic compounds have higher boiling points, so calcium fluoride has the higher boiling point. And then which one has the highest density? This is potassium oxide, sulfur dioxide. It's molecular. Ionic compounds have the higher density. So there are our answers. Now we at least mentioned the fact that ionic compounds are electrolytes. When we put an ionic compound in water, it breaks apart into its different ions. So we take sodium chloride as a solid, we put it in the water, it's going to break into its sodium ions and its chloride ions. It is no longer sodium chloride. The sodium ions are completely independent of the chloride ions. So here is our sodium chloride solid. We put it in the water, and now they're floating apart. The fact that those ions come apart, that means that it conducts electricity because these are charged. They can move around. Electricity requires charges to move around. On the other hand, molecular compounds, molecular substances, don't dissociate in water. If you put sugar in water, those sugar molecules stay sugar molecules. It's just they're dissolved in water rather than being a solid sitting on a countertop. So another example is methanol. This is methanol. You don't need to worry about this formula. But when you put methanol liquid into water, it is still methanol. It didn't break apart at all. And the same thing happens with our molecular elements. Oxygen, O2 gas, goes into water and just stays O2. It's just dissolved in water rather than being out in the air. So that's the very basics of our compounds. In class today, we're going to talk a little bit more in details of how these compounds come about. See you in class.